Welcome to an end-to-end from start to finish video on making the complete Viking spear. In the Viking era, the spear was the most common weapon. It had long range and was much cheaper than a sword. The wolf-tooth spear in particular has fascinated me since I first saw it in the Swords of the Viking Age by Ian Pearce. In this video, you will see me recreating a famous Finnish spearhead, including its wolf-tooth pattern. The original spear is currently in a museum in Helsinki and pretty much looks like the spear you saw in the intro sequence. The anatomy of a Viking era spear is a fairly simple one. It is a weapon with a long wooden shaft, frequently made from ash, and has a pointed tip of metal and can be used for thrusting. To attach the spear point to the wooden shaft, the spearhead needs a socket. Since steel was expensive, the socket was usually made from wrought iron. However, the cutting edge will be high carbon steel, and just like the original, there will be a wolf tooth as well as a twisted star pattern. To create the socket, I need to have enough wrought iron. I'm using old wagon tires that I forged into rectangular bars and are now forge welding together. This will give me enough material to forge a 5-inch wide sheet of wrought iron. For those of you in metric countries, that's roughly 12.5 centimeters. I need to use a sledgehammer before the wrought iron has been reduced to dimensions that fit under the power hammer. This is also a reminder how much this project is made easier by modern tools. I am sure many of you may be wondering what all of this has to do with making a spear. Well, that's a good question. Back then, even just acquiring the iron would have been quite expensive. Most likely a blacksmith would have acquired it in bars and would then also have to forge it out into a sheet, similar to what I am showing here. While I hope that my videos may be interesting as well as educational, it is difficult to capture the full atmosphere and visuals of the process. Perhaps this provides a different perspective. By now, we have spent a lot of time and effort just into making a white sheet of iron. The dimensions are about right now, and it is time to form and forge weld the socket. Tony and I created enough wrought iron plate for 2 spear sockets. Right now, I'm cutting it in half and will clean up the sides. The next step is to determine the right taper. Remember, we will form the socket as a cylinder, and that means that the width needs to be roughly the diameter times pi. The Finnish spear socket had a diameter of roughly an inch, 2.54 centimeters at its base. The other dimension does not matter quite as much, as we can taper it later. I am grinding in a scarf on both sides, so that after forge welding all seams in the socket will disappear. You might think that sounds great, but what is he doing now? Another piece of steel being cut? How does that fit into the picture? Let me explain. To help with forming the socket, but more importantly to help with the later forge welding, I need to make a mandrel that fits inside the socket. So, what I'm doing here is to take a bit of round stock and taper it into the appropriate dimensions. While the final shape needs to be round, I first create a square taper that I will then forge to octagon before finally rounding it. The mandrel will have a limited lifetime, since it will be heated up close to forge welding temperatures, so I expect to perhaps get 5 to 6 sockets out of it before I need to make a new one. After a while, I am happy with the dimensions, and the only step remaining is to do some cleanup on the grinder. Thinking about forge welding, this cleanup is actually a little bit counterintuitive. We want a lot of scale on the final piece. However, we'll worry about the lack of scale later. Right now, let's actually get to forming the socket. I will use a swage to assist with the operation. When forming a socket, the order of operation is quite important, so let's look at the mechanics a little bit. As you can see, I'm trying to bend the plate by supporting it in 2 places on the swage block and hitting it with a hammer in the air. It is important to start bending from the outside to the inside, because the more the plate is being bent, the less space the hammer will have. Now I'm switching over to hit the socket on the outside and will slowly bring the edges together. The important part is that the socket ends up with an even taper and that the edges have enough overlap so that they can be welded. After a lot of fine adjustment, I'm finally happy and the socket is ready for forge welding. As we will be heating up the socket with the mandrel inside, I coat the mandrel in graphite to make it easier to extract later. Forge welding works best when the material to be welded is completely free of scale. That's a little bit difficult to accomplish when the socket is essentially closed already. We'll try our best here. The challenge I have with forge welding sockets is twofold. The material is thin and cools down quickly. Also, since it's thin, it is easy to overforge it. The socket right now is not shaped right and needs to become more slender towards its top. To taper a socket or tube, I use a V-shaped die underneath the power hammer. It is important to hold the socket completely horizontal to the die and rotate it smoothly. Also, the hits from the power hammer need to be quite gentle. After I'm reasonably happy with the socket, it's time to prepare the wrought iron that will form the core of the spearhead. I'm forging it roughly to the dimension of the top of the socket to make it just small enough so that I can insert it. To prepare for welding, both surfaces need to be cleaned and free of scale. Also, to create a smooth transition from the socket to the core, we need to scarf the socket, and that will prevent a visible seam and step we would get otherwise. Once everything fits tightly together, it is time to go back to forge welding. At this point, I would also like to say a big thank you to Jim Austin from forgedaccess.com who showed me this technique. If you're interested in any of this, Jim teaches great classes in Oakland. Check out his website. Once the welding is complete, I go back to fixing up the taper, since the forge welding created quite a noticeable transition in diameter. After I'm happy with the taper, the part of the core that sticks out needs to be prepared. As with all my pattern welding, I like bars that are roughly 3/8 of an inch thick, that's about 9 millimeters. I am also forging in a small tip, but that's about it for preparing the core of the spear. Now we get to pattern welding. I have a number of already prepared pattern welded bars from previous projects, and Tony and I am choosing the one that looks the best. In the pictures you saw earlier, you may have noticed that the twisted patterns on the spearhead came from one bar with different twist directions and a hairpin weld. Before we can twist, we need to prepare the bars, which starts by cutting them to the right length. The first step is to weld on 2 supports for my twisting jig, and slow motion makes that look almost magical. Once the bar is in the twisting jig, I'm using the oxyacetylene torch to heat the bar to a bright orange and then slowly twist it. My method is to heat up roughly 2 inches of bar and then make a constant number of twists so that the pattern stays even throughout the whole bar. To prevent the bars from shearing in the corners, I usually put on a slight chamfer to reduce the transition angle. With the jig and the torch, twisting is usually a fairly quick process and becomes very repeatable. Frequent brushing helps with removing scale and keeps the bars cleaner, since they need to be forge welded back to square later. I twisted left for one half of the bar, and now it's Tony's turn to twist right for the other half of the bar. Once all the twisting is done, we use a wire brush on an angle grinder to clean up the remaining scale. My usual philosophy is to keep everything as clean as possible to reduce the rate of failure. Since all of this work consumes so much time, I really want to avoid starting over. After twisting, the bars always need to be forge welded back to square before they can be used any further. As with all my forge welding, I do this in sections and make sure that the bars are hot enough for liquid flux to squeeze out easily. To maintain the same dimension, I use a spacer on the power hammer. Any true blacksmith would be horrified by what is coming next. I need to bend the bar precisely in the middle, and I'm doing that freehand with a torch. I have many excuses for that. The Cyplus forge was not running, and the propane forge does not give me localized heat. However, I don't have any excuses for what you are seeing here. That seems like a terrible way to bend the bar in the middle. So let's use the coal forge after all and do some corrections with the hammer. To successfully weld the bar I just bent to the core of the spear, I need a very precise fit without any gaps. As I had heated the bar for bending, some of the resulting scale needs to be removed again, and a small file is appropriate for the job. Everything seems to be fitting now, and I really hope that all of this is going to come together. A failure here would ruin all the work done so far. The next couple of minutes are going to determine success or failure. I will let the action speak for itself. Everything looks like it came together. I will do just one more light welding pass before declaring victory. So far, you have seen 4 different forge welding steps. There are several more to come. Some of these steps could be combined, but I prefer to do them separately since it gives me more control. In preparation for the next step, I need to taper the tip into a much sharper end. This is necessary since we need to fit the cutting edge of the spear over the core that we have built up so far. Now it's time to prepare for creating the wolf tooth pattern. I already have a block of reasonably high layer steel we will be using for the cutting edge. Before it can be used, I need to forge it to the right dimensions. It needs to be about 3/8 of an inch thick and much wider. I want the bar to be at least 2 inches wide, so that the spear core will fit right into the center of this bar. As before, I'm using my trusty sword fuller to help with widening the steel in the power hammer. Working on the fuller can bend the steel, and sometimes corrections on the anvil are useful to get everything back in shape. I'm finally happy with the bar. While it may be hard to see, this is what will form the outer layer of the spearhead. The next step is to cut it open in the middle for almost its entire length and start forging in the teeth. We could have done this with a hot chisel as well, but that would require extra work to square things back up. You will see why in just a few minutes. Before I continue, I need to clean up the cut from the bandsaw with a fuller. One of the nice things from working with steel is that when hot it can be moved around. For example, when a part of it is in the way, we can move it somewhere else. Now comes the step that many of you may have been waiting for, the creation of the wolf tooth pattern. I made the double chisel that I'm slowly moving down each arm of the spearhead. The double chisel gives me very even spacing for the teeth, but also has its drawbacks. For example, when starting a new tooth, the chisel needs to be well aligned, and it is easy to double cut a tooth. This is how it looks after we are done with one side, and now let's quickly finish up the other side as well. As the chisel is made from hardened steel, it needs to be cooled occasionally. I am conducting a second pass over the teeth, which helps with evening out the spacing. Here's a close-up on the teeth, and you can also see some that I cut twice. Some of this will be cleaned up with files, and some will disappear when forge welding. What you see now is my method that allows me to do all the operations by myself. For the spearhead, I fortunately had Tony's help, so could have tried to do this differently. However, this is the way that I found that works for me. The basic idea is to take wrought iron, which is very soft when hot, and use the cold high carbon steel as the form into which to fit the wrought iron. Even when using a hydraulic press, this is still a little bit of a struggle, and Tony is helping to hold down one side of the wrought iron strip with the hammer. Here is how it looks like after the wrought iron has been formed. Once the wrought iron is hot, I have enough time to press 2 to 3 times before the heat is lost and I need to go back to the forge. Alignment is important here, and you may notice that the bar is bending away at the end. I somewhat corrected for that, and fortunately there is enough material so that it should not become a problem. Before I can forge weld the wrought iron teeth to the outer part of the spearhead, any scale that is built up needs to be removed again. A couple quick tack welds hold the wrought iron in place but will not form inclusions in the finished product. Now it's back into the forge where I bring everything up to welding heat. The power hammer makes this an easy exercise and lets me hit precisely where I need to. Without the help of the power hammer, an assistant would have to hold a set hammer. Having both arms out of each other's way also means that I can forge weld both sides without needing to make any adjustments. That's it. Our spearhead has a wolf tooth pattern now, and the mystery of how to create it has almost been explained. The wrought iron has been combined with the high carbon edge steel and is now being forged to the same width and thickness to prepare for more forge welding. I am making sure that the surfaces are straight and free of scale. A great benefit of steel is that it is very malleable when hot. This allows me to bend the arms back into place. All of these manipulations are a little bit scary since I don't want any of the forge welds to come apart, and wrought iron can be a little bit tricky. When forge welding, it is also very important to have a good fit. Since I cannot aggressively forge the shape, closing up gaps will not be possible. As you can see here, the fit is not good at the moment and it takes a couple of iterations to get it right. Closing the gap at the top opens up the arms, closing up the arms creates more of a gap at the top. Since the adjustment was done at high temperatures, any newly formed scale needs to be removed again. We are getting closer now to the final forge welding step in this project. As before, any failure here will doom all the work we have done so far. So, I'm having a fair bit of tension about what is going to happen. To counter that, we are taking our time and slowly tune everything till it's perfect. As of now, you may still be wondering how this misshapen construction you have watched for the last 20 minutes will ever turn into a spear. Just have a little bit more patience. The time for the final forge weld has arrived. Because of the irregular shape, forge welding on the power hammer is not going to be possible, so I have to forge weld by hand, which always is a little bit more difficult. However, it looks like everything came together alright. Now it's time to slowly create the right profile. I'm still not entirely happy with this process since it wastes a fair bit of material. So, instead of forge welding the material back into the socket, I'm only fullering it somewhat and will remove the rest of the material on the grinder. The plywood form closely resembles the dimensions of the finished spearhead, and that's what we are using to approximate the final shape. The grinding you are seeing here is also good for removing any of the remaining tack welds. I am now removing the scale, covering many of the forge welding steps, so that I can see if everything has come together correctly. There are a couple remaining forging steps, and one of them is to establish the edge bevels. Another challenge is to avoid distorting any of the pattern welding, so there are many iterative adjustments to make sure that the edge lines flow smoothly and that everything remains centered. I hope that by now you have a much clearer appreciation for all the work required to make one of these spears. While I started with creating the socket at the beginning, I'm getting back to it now to ensure that the taper is smooth. And here is the result, a spear fresh from the forge with magical patterns hiding in the steel, just waiting to be revealed. I noticed that the pattern was a little bit distorted and am now forging the bevels a little bit more to correct the overall appearance. As you may notice, I'm making only very slight corrections and frequently check the shape of the spear. Another area that requires final corrections is the socket. If you look closely, you will also notice that I did not completely weld at the very end of it. That's unfortunate, but there's nothing I can do about it at this point. Finally, all forging has been completed, and it's on to the grinder to remove all scale and prepare the spear for heat treating. You may notice that I'm grinding the blade on the platen. I need to be very careful to not remove too much thickness from the spine, and probably would be better off grinding a concave profile on a big grinding wheel. Whenever I heat treat, I'm trying to remove any vertical grinder marks since they might lead to cracks when quenching. Another moment of truth has arrived. I have prepared my quench tank of high-speed quenching oil and will normalize the spear once before hardening it. Look closely and watch the recalcitrance. Did you notice the visible rise in temperature when the crystal structure changed? If not, watch again, it's pretty cool. Without further ado, let's quench and harden the spear. After heat treating, the pattern including the wolf teeth are clearly visible. This is a great reward for all the work done so far. Now it's time to create the final profile on the grinder. I will do this with progressively finer belts. I find a slowly rocking motion of my whole body the easiest way to maintain an even grind. Alright, everything looks pretty good so far. Before I can place the spear in ferric chloride to bring out all the patterns, I need to clean it and remove any oils that might interfere with etching. I usually leave my blades in the ferric chloride solution for about 10 minutes, but let's just skip that wait. What follows is my usual routine after etching. It involves some metal polish and some iron oxides. This is what works mostly fine for me, but that very much depends on the materials. For this spear I was using wrought iron from a different source, and it does not stand out as much against the high carbon steel as I would have liked. Alright, here's the polished pattern. The only thing that remains is to make a shaft for the spear and also give it some light use. At a close-by lumber store, we picked up a large piece of wenge. This is a hardwood with a very straight grain. Historically, ash would have been the likely material, but that was not at hand. Originally, we wanted to use a spoke shave to round the wood, but since it was so hard, we quickly gave up on that. Instead, I'm using my bend saw to cut the wood roughly to the right dimensions and then use the belt sander to round it. I have also lost Tony's help, and cutting these long pieces requires quite some juggling. As with blacksmithing, my approach to rounding is to transition from square to octagon first. The belt sander with a rough belt makes short process of the rest. To avoid a lot of dust, I'm running a big dust collector and my powered respirator. Now comes the fun part, fitting the shaft to the spearhead. I'm using some machinist blue inside of the shaft to make it easier to find the high spots on the wood. You will see in a minute. This is an iterative process and takes a few times before everything fits tightly. One piece of advice: Don't stick your freshly polished spearhead into a rough leg vise, unless you want the spearhead to look less freshly polished afterwards. Once the wood is sanded, I'm applying a couple layers of boiled linseed oil to finish it. That makes the wood immediately look much nicer. There are different ways to attach a spear to a shaft. I'm using a very simple one here. I'm drilling one hole and then will use a single square nail to attach it. Other options would have been to rivet it, but ultimately the goal is to prevent the spearhead from falling off while still making it relatively easy to replace the shaft in case it should break. For square nails not to break the wood, it makes sense to pre-drill the hole. Alright, this was the final step. The spear is now officially completed. So let's take a look at it in its natural habitat. I have nothing fancy to test it with, so I'm sticking it into a broken tree branch just for the heck of it. To get a sense for the size of the spear, I'm providing myself as reference. Here's a final view of the finished product. I hope you enjoyed following me on this journey and stick around for future videos. Don't forget to subscribe to my channel and share these videos on your social networks with your friends. I would also like to thank all my patrons for their support. For more information about my work and process, visit the link to Patreon. See you next time.